The universe is expanding, and that expansion is speeding up, which is the opposite of what we expected. We haven't been able to figure out exactly why, but we have thought it might have something to do with dark energy. And a certain paradigm-shifting hypothesis may just resolve all of these uncertainties. And if it's true, that means gravity has mass. Okay, but let's back up. There are many weird and wonderful mysteries out there in space, but one of the most perplexing is the fact that the universe is expanding. We know this because we can see the Doppler effect in action when we observe distant galaxies. You may know of the Doppler effect as that distortion of sound that happens when, say, an ambulance approaches. It sounds different when it's far away versus when it's right next to you in the street. That same thing happens with light waves, so we can tell where galaxies outside of our own are going and how fast. These observations fit within Einstein's theory of general relativity. In fact, the universe's expansion is one predicted outcome of his theory. But here's the catch. Accelerating expansion doesn't fit with our current theory of gravity. According to Einstein, the universe's expansion should actually be slowing down. There are lots of different ideas about what could be causing the inexplicable acceleration of this expansion, and one commonly suspected culprit is something called dark energy. And we're not entirely sure what that is either. But now we might finally have an explanation. A theory proposed by Professor Claudia Durham at Imperial College London suggests something pretty radical, that gravity has mass. See, within the standard model, there are 4 fundamental forces that pretty much govern the way the universe works. 3 of those 4 forces have carrier particles that we can observe. The weak force has bosons, the strong force has gluons, and the electromagnetic force has photons. That 4th force is gravity, and hypothetically, its carrier particle would be called a graviton if we could find it, which we haven't yet. In Einstein's theory of general relativity, gravitons should be massless. But in Durham's proposal, the graviton has mass. This would resolve our confusion about the universe's expansion. If gravitons have mass, then gravity as a force isn't as easily able to propagate over long distances. The math tells us that gravity is actually weaker on cosmological scales if gravity has mass. So gravity wouldn't be able to slow down the expansion of our universe. And this also means that maybe we now know what dark energy is. Or rather, we've known all along because it's gravity. If gravity itself is a particle with mass, it takes up space, it is stuff, then it could be fulfilling the role we've assigned to this mysterious dark energy. And scientists are calling this the theory of massive gravity. So just very casual, this work may have upended some of the most fundamental things we believed about the universe and solved some of its biggest mysteries. No big deal. But it's not just interesting for that reason. The idea was actually originally proposed in the 1930s, but Durham and her co-authors reignited the debate around it in 2011 with a pretty controversial paper. There was a big backlash from others in the cosmology community who didn't believe that this could possibly be true. But in the almost 10 years since, the work has withstood the tests put to it. It's been steadily gaining credibility and sparking conversation about the nature of our universe more than ever before. The math checks out. But now we need to look for evidence we could observe and record that might empirically support this theory. Luckily, we live in an era where we can measure gravity, although indirectly, via gravitational waves with tools like LIGO. The future of gravitational wave astronomy may allow us to measure and observe gravity and its behavior and its effects on the universe in ways that could blow this whole case wide open, helping us settle this question of whether gravity is as massive as it seems it could be. Any other mysteries of the universe you want to see us cover next? Let us know over on Instagram. We're at Seeker, and I'm on there too, at MarinB. Keep coming back to Seeker for all of your paradigm-shifting news, and as always, thanks for watching. I'll see you next time.